can download full spatial coordinate database into your local site to reduce your detection time. And then we get the latitude and the longitude edges. After that, we want to measure the spatial snapshot futures to generate spatial snapshot futures. We use entropy to measure the degree of uniform distribution. For example, this is each frame is a time zone, and if this IP located at the same time zone, the entropy is low. If this IP distributed in the different time zones, the entropy would be high. Okay, so we use time zone to discretize the geographic system space. After that, we calculate the distance between A1 to the consumer and the provider distance, and get the minimum distance for our calculation. And the distance is calculated by Euclidean distance from the physical coordinate edges. And after that, we can extract several features for detection. The first two is extend from the previous work, focus much more things on the temporal features, and the below 4 features is highly related on the we just mentioned features. And I briefed the Bayesian, why we use Bayesian network, because it exists various problems. So we construct the Bayesian network using K2 algorithm. It's a popular method in data mining domain, and construct the dependence graph automatically, according to the data. And we can automatically tune the probability to calculate the joint probability and do the detection. Okay, let me let you know the experiment. The first, I will describe the data set and some data analysis in public data set, and the evaluation design and the result, and some discussion. And our method still have some limitation, also reveals. Our data set we use 3 data sets. The first one we use NDS data set. This data set is published by the author of NDS 2008 papers. And then we self-collected data set. Actually, because if you want to generate a data set, is there some labeling problem, right? So we get some blacklist from the website, including the Alexa, FluxOR, Altus, and the DNS bill from different dates. And then we need to, Alexa is the benign, sorry. Alexa is benign and the black on top list. And we want to do the data synthesis. And the training one is 66% to the combined data set, Alexa and the FastOR. And the test set 1 is the published data set. The test 2 is combined data set with Alexa and the FastOR. And test 3 combine the other remaining data sources. This is the data set description. This slide just want to show that we try to consider with the real environment data distributions. It's a quite unbalanced data distributions. Test 1 is a published data set published by NDS 2008. This 3 data set is collected by ourselves. Okay. So the second thing we want to analyze is the left-hand side is the same time zone distribution of host, and the right-hand side is the different time zones to show the data set distribution. Why we want to show that? Because it will lead the recall rate, high and low factors from the original data distribution. Okay. So actually, you can see in different time, in the same time zone and the different time zone, benign distribution and the fast-flux distribution is very clear. After that, we use our proposed spatial distributions to see the benign and the fast-flux. Actually, this is a good news before our final evaluation, because we can easily distinguish these two things. After that, we also analyze the spatial service relationships. Also, it is clear distinguish these two kinds of service. However, several instances is misclassified. Okay, we try to use three measures. The first one is accuracy. The second one is false positive rate. And the third one is ROC curve. ROC curve is a confidence degree to let us know how confident we do this decision. Following is the confusion matrix for both calculation. And our experiment goal try to answer the following two questions. The first one is how effectiveness of our method, and the most important thing is how efficiency of our proposed method. In these figures, you can see actually the black one is our proposed method. In test one, we have a slightly loose than the NDS's papers method, because we did not redo their experiment because we do not have their source code. However, we just compare with their papers result, and then the FSD sharp means we use the NDS 2008 futures and use our snapshot method to do the detection. Use Bayesian network, but without our proposed futures. And the third is our proposed futures. And we have a good result in several data sets. Okay. Also, we have more confidence. This is a ROC curve. We have more confidence to do the decision. And also, we have a low false positive. I think this is another efficiency analysis result. You can see FSD is the NDS 2008 paper method. It requires many times to complete the detection. And actually, our method just needs 0.5 seconds. Why? Because we collect the data, we do not wait the TTL time. So we can spend less time to complete the detection. And someone maybe have another question. How about maybe you have another trade-off? Yes, we need to keep the coordinate, the information. Yes. We give some real example. In the first real case study, the case one is same time zone distribution for host. So you can see the Facebook located in the West US and very close in their minimum service distance. And this is a fast-flux service, and it distributes different places. So their minimum service distance is quite large. Another example is from the different time zone. Okay, this the previous case, because they are located in the same time zone, so our first measure is useless. However, in the second example, you can see that we can easily distinguish these two cases. Microsoft actually it has another place. However, we also consider the minimum service distance and distinguish these two cases. And actually, as our observation, most of the fast-flux service network is cross time zone. And we give some discussion to compare with the effectiveness discussion. We define three types of error. This is not similar with the statistical error type error. Okay. And the first one is FSD could detect, but we could not. I think we think this is our limitation. And the type 2 is FSD could not detect it, but we can. It is our benefit or advantage. And then after that, the type 3 is both methods could not detect. We think it is a limitation for the further study.